Is that me or you?
It's go ahead.
In order to achieve that, the permit, in order to bring the material into Wisconsin and use it in a situation where typically under what's called at the time Administrative Code NR 528 would not have allowed the use of that material adjacent to any residential homes, which would have rendered it essentially useless in the use of even an urban application, or for that matter, an agricultural application would have problems, because it also affected, that distance was also problematic for feeding operations. So we had to go through have a series of leachate testing being completed. And in order to kind of provide some sense of if it was safe or not, and is this the meeting thing that's up on my screen? Is that on everybody's screen?
What I see across the top, it says WDNR aquifer criteria.
Hang on. Oh, it was on my screen. Never mind. Something popped up on my screen that obviously y'all weren't seeing. That's fine. I got it resolved now. So now I know what I'm talking about. So what this graph shows is the leaching metals that were evaluated compared to the Wisconsin groundwater quality standards. And we've highlighted where they've exceeded the aluminum or antimony or beryllium or whatever it is that exceeds the groundwater standards. And you can see blast furnace slag compares pretty well against topsoil, potting soil, wood mulch, bentonite, and the last row is actually multivitamins. So, you know, from a safety perspective, we were able to definitely show to the DNR and essentially anybody else that cares that this stuff is not going to leach some heavy metals that are going to be problematic for long-term effects on the environment. Go ahead.
Hey, Todd.
Yeah.
Could I just interrupt? And I'm wondering if we could see, if we went to a different view, that we could see the slides better, if it was actually a slideshow.
Let me try that.
There's a slideshow tab at the top, and I don't know if that would actually make that slide bigger.
All right, way up on top.
To the right?
To the right.
A little higher.
Up.
Higher.
Okay,
up.
if I can't go higher on my screen because it's the Zoom controls are up there covering up part of it. So
Barb, if you go, can you see the 73% in the lower right-hand corner?
yes.
If you go right to the left of that first icon,
I'll slide it.
Okay.
go to the far right icon. One over there. You go.
Oh, got it.
Click on that. That should be.
There.
Ah,
There we
that's
go.
better.
How's that?
Yeah.
Thanks,
Yeah,
Whitney.
Yeah.
Thanks. Thank you.
That's great. Hang on a second. All right. So as part of the additional testing that was required by the state of Wisconsin was some ecotoxicity testing, where we had to evaluate whether or not it would impact water fleas or fathead minnows, which are basically freshwater constituents that are used in various testing protocols to determine whether or not something's toxic in the water. Well, in our case, we used 3/4 inch slag material, and the water flea test was 48 hours. The flathead minnow test was 96 hours. Basically, it was to determine whether or not there would be any mortality. And in both cases, we passed it just about. We had some deaths in the water flea stuff, but other than that, it turned out almost 90%. So we passed that just fine. Go ahead. So we're not killing the fish. So how does this stuff work? So what you're seeing in front of you there's the rows are the size of the stone. So you've got AASHTO 10, AASHTO 60, AASHTO 10, which is a 3/8 inch stone. AASHTO 67, which is a 3/4 inch stone, and AASHTO number 3, which is a 2-inch stone. And the first column is pH, the next column is orthophosphate removal, and the third column is total phosphorus removal. And the testing done on this was we used 1, 5, and 10 milligram per liter solutions of phosphorus. And then the testing time ran from 0 to roughly 5,000 minutes or 72 hours, because in the case of infiltration systems in the state of Wisconsin, we have to have those systems essentially purged within 72 hours. So the tests were concluded at 72 hours. And what you can see in the orthophosphate column is quite remarkable, that after basically 6 minutes, the 1% or 1 milligram per liter solution is already over 80% removed of the orthophosphates. And after 10 minutes, you're over 90. And then after an hour, you're at literally 100%. And that's true for all three, the other two solutions. Once you get to an hour, you're just about to 100% orthophosphate removal using AASHTO 67, or a 3/4 inch stone size, which is very typical of the stone used in a lot of applications. If the smaller the stone, obviously, the more reactive, and you see that in the top graph, where you get your removal is quite fast, and that's simply because of surface area. Larger stone, obviously, at the bottom, it doesn't work as fast, as kind of a clunker, but nonetheless, when you use that in combination with the other two stones, you actually have an additive process. It's not, you get so much here and then you don't get as much down there. No, you actually get an additive process in how it removes phosphorus. So having a subsurface layer of larger stone below a surface layer of smaller stone is a good thing. So go ahead. So we really had to take a look at also, how long does this stuff last? And really the only way we can do it is essentially establishing some idea of what's the annual runoff, and then what are the concentrations of phosphorus that you have to deal with. And then equate that to some lab testing that we did in order to understand how fast the material essentially lasts in a laboratory scenario. So go ahead. Go ahead. So we looked at, we did some computations using the WinSlam computer model, which is the computer model that the state of Wisconsin requires us to use when we do water quality monitoring or design. And we looked at 5 different communities along the Great Lakes: Buffalo, Chicago, Duluth, Erie, and Green Bay. And then we broke it down into a high density residential scenario, a low density residential scenario, and an industrial parking lot. The high density residential was like a typical Milwaukee lot, okay, 80 by 100 kind of thing. The low density residential was a 1 acre suburban lot, and then the industrial site was a 1 acre parking lot. And you can see the kind of orthophosphate annual amounts, or I'm sorry, the concentration of orthophosphates that were available, as well as the annual volume of water that was then computed. Go ahead. And then in a laboratory, we had a system set up where there was testing done with a 1 milligram per liter solution of orthophosphorus. What we would do is we would have 24 hours of aggregate wet, and then we dry it for 24 hours. And we do that repeatedly until the removal rate of orthophosphorus reached roughly 50% per weight. And that's what the diamonds are illustrating. As you can see, the drop is every 24 hours on, off, you lose a little bit of potency. until we got down to that 50%. We also tried some 72-hour dry times because there was information, certainly technical data out there that suggests that if you give this stuff some ability to recharge, that it will. And you can see that it leveled off in the first part, and the second time we did that, it actually bounced up a little bit. So there's some validity to that thought process. But anyway, this gave us the numbers we needed to basically put into a spreadsheet. Go ahead. A spreadsheet that allowed us to identify essentially how long this material would last under various watershed scenarios, and then how much of the material would have to be applied to those watersheds in order to gain some level of longevity. So in the case of what you're looking at here, you're looking at the different communities and the different land uses. And then, you know, if we had if we had 10% of the watershed treated with slag in the case of Buffalo, you're looking at roughly between 16 and 26 years of longevity. Now understand, all of these numbers are based upon 1 milligram per liter, and in the urban environment, it's pretty difficult to get up around 0.5 milligrams per liter, simply because of, you know, the way, because of it, that's really what you're looking at from a leaf degeneration or vegetative phosphorus from vegetative runoff or fertilizers. So it's not, you're rarely going to see 1 milligram per liter, which is essentially what these numbers are based upon. And the other thing in the real environment is you don't get a constant, you know, 1 milligram per liter flow of phosphorus every time it rains. You may get 0.2, you may get 0.01. I mean, the variables are so dramatic and usually very low that my opinion is these numbers are extremely conservative, I guess. And so when we talk in terms of maybe a 25-year longevity, it really might be more like 50 years of longevity. But again, it all depends upon the concentrations of phosphorus. In an agricultural scenario, you might have a much higher concentration simply because of the fertilizers used, or the runoff from barnyards or such, where it's from manure. And those concentrations could certainly exceed 10 milligrams per liter. But then there is also times when it's going to be lower. So, you know, I don't think we all have a definitive number on how long it lasts, but I would suggest that it would certainly last a lot more than 10 years in most applications. Go ahead. So where are we at with regulatory oversight? Well, when I got involved with this back in 2016, 2017 to get the product to be used up here, we were under NR 528. That since has been changed under Act 285, where they removed the steel and iron slag from being considered solid waste. The one caveat to that is that you still have to have an exemption from what's called encapsulation as defined by the EPA. And what that means is that the slag material, even though it's not considered solid waste, if you're going to use it for in any kind of sort of environmental application, it has to be what they consider an encapsulated. Now, that means, at least the way I've been told through the DNR, is that means it has to essentially be under pavement or integrated into pavement. So in order to avoid that problem, we had to get an exemption from that rule based upon our original exemption from NR 528, which was successful. So I guess my point is that to get this material, you can only get it from one source in Gary, Indiana at this stage in time. And that's through the Arcelor Mitel integrated mills, which are, the slag material is managed by a company called Phoenix Services. But, you know, I can give you more information on that at some other time. But right now, that's the only company that it has the essentially gotten the okay from the state to use their material as a stormwater media. So the other thing that's out there that I've just come across is the code 782 by the NRCS. The importance of that is that it's now in the Wisconsin Field Technical Guide, which I believe allows you to use that when you're looking at trying to use or achieve grants from USDA. If you've got, say, an agricultural partner and a local county agent that might be interested in helping you guys implement something on an agricultural basis, since there's a technical now code for phosphorus removal system, and I've read it, it's pretty good. I disagree with some of it, but nonetheless, it's there. And it does allow for slag material. It allows you to look at possible grant applications to USDA and federal government. So I think that's important to know. Go ahead. So from an urban perspective, this is a project that was done. I designed this in the city of Cudahy, Wisconsin. It's this slag application under a permeable pavement system. You can see they're just dumping slag material into the trench. It's an aggregate. That's all it is. It handles just like limestone. You don't need any special PPE or anything to breathe. I mean, it's not like you're gonna die from this. It's no dustier. In fact, since you're using clean stone, it's really, there's no dust at all when it goes down, and it can be compacted to the point where we need compaction, and works really, really well. Go ahead. So just wanted to show you some of the monitoring results. If you look at the bottom graph, the top graph is a little difficult to understand because it was pre and post sampling back in 2018. The 2020 stuff is a little bit more cohesive in the sense that it was done on the same day, you know, at the upstream and the downstream ends. And you can see that even after it being in literally for 2.5 years, the orthophosphorus removal from between the pre and post is literally about 80% reduction. Total is even more, the reductions there. I think the thing that's really interesting is the chloride removal, and we've seen that in both cases, even in the 2018 monitoring data, that they were picking up chlorides in the pre-treatment sample, and yet at the post-treatment we're seeing none. So when you start talking salt removal, that also becomes a very a big deal when dealing with urban environments. But it's, I guess the point is it's still working very, very well. We're still seeing remarkably lower phosphorus numbers. I mean, to the point of almost non-detection, which is really what you're trying to achieve. Go ahead. So from an agricultural perspective, so you can see that the cows laying there in the field, the water pretty much goes to both sides of the field and then down to the ditch on Rock Road. Go ahead, hit the button.
Hit the button
Hit the button, or go to the
to go
next.
to go to the next slide.
Yep. Oh, didn't work. Well, anyway, go back. So there's supposed to be an automated thing where it's going to pop in some treatment locations, but obviously that's not going to work. So we'll wing it. So where the water would come out would be on the, you can kind of see the drainage patterns there, and it all ultimate ends up in Rock Road. Well, point is you could line that ditch literally from one end of that feeding pasture, literally past the house, and you would have enough length and depth and rock to essentially treat that manure system or that feeding lot by removing the phosphorus from that runoff. Maintenance wise, it's nothing more than maintaining sort of a ditch line with, you could have some native grasses and such growing through there that would act as an additional biologic removal. And then your maintenance is nothing more than cutting extremely high in the grasses if that was necessary. Go ahead, next one. Applying it to drain tiles is certainly, I think, really viable alternative. This is actually a piece of farmland in your watershed. I don't know exactly, I can't tell you exactly where, but I remember pulling it out of the, off of that area, the aerials, knowing that this was 14 Mile Creek. And this is roughly a 77 acre watershed. The ditch is roughly, about a half mile long. Annual water that's going into is about 60,000 cubic feet. Again, that's been a computed number. If we assume a half milligram per liter phosphorus concentrations sort of on the average, you'll see certainly a life cycle of roughly 25 years. And there's a kind of a typical cross section of how that might look on the right-hand side of the screen. But again, certainly a viable alternate way of using this material on a larger scale. Go ahead, the next. So, and then you could also consider armoring your outfalls with this material, whether it's larger riprap size, you get 6 to 8 inch size stone aggregate, or you can kind of do it old school. Instead of using what's typically now where when you build outfalls is you use a geotextile fabric underneath it to provide keep the soil from underneath from piping through it. Well, the way we used to do it when I was a much younger guy is we would design it with a bed of essentially aggregate, and you could use blast furnace slag aggregate as your bedding stone. So you could still armor with limestone because it's certainly heavy and a great armor, but you could actually have a filtering device underneath it that would give you secondary phosphorus removal capabilities. And then you could do things like shoreline treatments, ditches that go into shorelines. You get anywhere that you're using a stone material for something from a drainage perspective, you certainly can integrate slag material because, like I say, it's nothing more than an aggregate. You can confine it in some of these geotextile fabrics and confinement cell materials. And Scott Bordeaux is an expert at all that. And even though he's retired, he still remembers it all. So if there's any questions on that, I'm sure you can answer them. But I mean, there's all sorts of ways to apply this material. And I think it's just a matter of what you're looking at and how you're trying to achieve. So next one. Can also, where you have some gradient, if you want to put it, say, in the core of a check dam where you can actually get some treatment with the check dam material, you can bag up 3/8 material, use it as the middle of that dam. Water's got to pass through it, so if you've got some kind of material in there that actually might absorb some phosphorus, why not? It's an inexpensive addition. It doesn't create a whole lot of. It's not a design issue either to do it from my perspective, because I've designed many of these check dams, and it just makes sense if you had a core inside of it that actually might provide some ability to do water quality, as opposed to just simply holding back nutrients, or solids. Then why not? Go ahead. So this is Sheboygan. I know that you guys mentioned Sheboygan beginning of this discussion. I was brought up to Sheboygan this past summer because I had talked to him back in 2018, right after they built this in 2017, and in 2018 they were already having some issues with it. And I told him, I said, well, you might be having some problems with it becoming a kind of a big block of cement. And explained to them why. Well, anyway, 2 years later, they called me and said, well, it's turned into a block of cement. We need to retrofit it and make it work. So basically what we did is we simply just put a layer of blast furnace slag on top of what's already there. And that now acts as a filtration device. And it's working, but not very well. And I think it's probably because this system is, the water is just actually going through it too fast. Go ahead, next slide. This is what it, on the left is, you can see the old media is what's been, or the top, there was some pea gravel all over the old media, and that's the old media. You can see the blast furnace slag is the two piles. That actually what happened there is they had the system basically has no hydraulic gradient. It's almost dead flat in the system itself. So the water comes in almost under pressure from the 10-inch drain tile, and then it goes to this very flat pad, and then it exits through a dead flat outlet device that then reconnects to the drain tile. It doesn't flow fast, but it does, believe it or not, flow. The problem was they used steel slag material, which is highly, very reactive to phosphorus, but it also can leach a lot of calcium, which at the time when they installed it, they ended up with some calcium chloride on the metal agra boxes they used for control, and they had, you know, up to 3 inches of calcium chloride growing on the metal. So there was a lot of calcium happening with that system, and they were getting remarkable results of orthophosphate removal. I mean, seriously, up to, it was literally 90%, 99% removal. But it only lasted for a couple of months, and then that started falling off. And what happened over time was because there was no gradient on this thing, the steel slag and all the calcium turned it into literally a block of cement. And so it ultimately just stopped functioning. Now, go ahead, next slide. After the blast furnace slag was put in, these are the results of the phosphorus removal. We're getting some, but it's not what I would expect. It's very low, but yes, it is removing some. I think that, like I said, I think we have to have at least a residence time in that case, probably at least of an hour. And I think it's getting more like 10 minutes at most. And then I've been told recently that the upstream farmer had done some so-called repairs on the tile, but I think it compromised the tile, and there was some sediments and stuff that got down into the system. So they're waiting to the spring to get it kind of all flushed out, and then we'll start playing with some of the gates to see if we can't get this thing to work a little better. I have a lot of confidence in it, but right now it's just not. It's not giving me the good results I want. I mean, it's giving me some, and I guess any phosphorus removal is good phosphorus removal, right? So go ahead. So in summary, you know, the slag material is basically it's environmentally safe. It's not going to require any kind of landfilling once it's been expended. It can be used as secondary, like for road gravel or pathway gravel. I mean, it's like lava rock. It's really what it looks like. And it has a great ability to uptake phosphorus, especially orthophosphates, which is obviously what, you know, turns our lakes and rivers green. And that's the big elephant in the kind of elephant in the room when we people in the water resource industry talk about trying to get rid of orthophosphates or phosphorus, period. A lot of us talk in terms of, oh yeah, you know, we know how to get rid of total phosphorus. Well, yeah, there's a lot of mechanical means to make that happen. And even simple things like wet detention ponds that you know, allow for you know, sediments to drop out. They'll take the large particulate phosphorus with them, but what they can't get out is the dissolved ortho stuff. That's what blast furnace slag does, is it removes the dissolved phosphorus, the stuff that's reactive. And that's the important part. So with that, I'll take any questions. That's the end of my presentation.
Any questions for Todd?
Yes, I have one. In one of the charts,
Yeah.
you showed that there was nitrates removal, which looked pretty decent. Can you speak to that?
Again, it was and that was in the monitoring for Cudahy, and they just, as a matter of course, wanted to see if you know, all these different elements if they were being removed, and they decided, well, let's try nitrates too, right? And again, it was one of those aha moments for us, because we again never expected the nitrate removal. We know that slag can remove it. We just didn't realize it was going to do it that well. There is some technical data on that describes that process of nitrate removal. It's very similar to how phosphorus is removed. We haven't really paid much attention to that, but obviously from an agricultural perspective, it's very important. So urban wise, they don't, you know, it is what it is. You know, they're more concerned about chlorides and meeting, you know, their MS4 or TMDL requirements, whatever they might be. And they're typically, you know, suspended solids, in particular phosphorus. So again, it's a good thing to have, I guess, is that we're seeing a fairly significant removal of nitrates.
Yeah, it's one of the elements that we're interested in measuring. So I assume that reduction of nitrates would be beneficial to us.
Right, right.
One of your slides showed a scenario where what appeared to be a ditch was lined with your slag. And I'm a little curious as to what amount of interspersion of silt will do and how quickly it will affect your, if in that application, how quickly it would affect the substrate.
That's a great observation, great question. And sadly, I don't have that answer because I haven't had the chance to actually install something like that. But that's a design consideration that I'm certainly aware of. And I think we'd have to have some level of, for lack of a better term, pre-treatment, but it might not be pre-treatment. It may be more of some way that you're going to have, you may have to integrate with a ditch scenario, some kind of a check dam scenario also, where you're going to have to sacrifice a section of it in order to allow for that sediment to drop there in order to preserve downstream. You know, that's going to be very a strong challenge from my perspective on how that gets done. And I don't know, I don't have any solid answers for that. That's unfortunately one of those things that you find out in pilot projects to say, oh, gee, we should have done that differently, or that worked great. You know, it's like, you know, in the case, for instance, in the case of the Cudahy project, you know, we had set this up to be able to monitor all the discharge, and we're going to have all this big monitoring project because we assumed that because the soils underneath were the soils in the area that we were building this were clay. I mean, it was Cudahy clay, pure and simple. And we didn't anticipate any kind of infiltration. Well, lo and behold, we're finding that just about every drop of water that goes into the system infiltrates. So the good news is it goes away and we get 100% removal. The bad news is we can't get any good monitoring data. So I guess my point is every pilot project comes along and you have something that's going to be that aha moment. Oh, gee, that's great. We should have done that. We keep repeating that, or that didn't quite work the way we wanted it to. Maybe we got to do it a little differently. You know, I've designed a lot of sediment basins and sediment control systems. So I don't see that that's, you know, that's not an impossibility to integrate into using slag material. Slag material is really what you want to think of it as integrating it into current practices so that you can get a sort of that double whammy. I mean, if you, for instance, follow the DNR technical standards for grass swales, you can certainly look at ways to integrating slag into that grass swale in such a way that it would perform as a phosphorus removal or as a secondary maybe primary with secondary biologic element being the grass or turf that's coming out of that's being grown in the swale. So I think there's a lot of different ways to look at this because it's kind of a new frontier. It appears to work quite well in the environment, and it's just a matter of deciding, you know, where we're gonna put it and how we're gonna use it. I've talked with Presto, the Presto company up in Appleton, And they make this plastic mat that looks like honeycomb. They're confinement cells. And we've talked a couple of times about pilot projects where we would use that as the mat that would actually hold the material, especially in a ditch situation, because you're going to still have velocity of water moving it over it too. So you can't have the material rolling, down to the end of the ditch with a heavy amount of water. You got to have some way of holding it in place. So using some kind of a containment mat made a lot of sense, and they're interested in doing something too. So I think, there's some opportunity out there to do some different things. We just need to find the right, I guess, owner or land person who's interested in doing something like that, and seeing where we can go with it, maybe with some grants through whether it's TRM or it's USDA kind of money.
Thank you.
I have a question. I'd like to build on what John had asked about, and I got a couple of questions regarding that. And I'm thinking, John Andresi, who asked the prior question, does our water testing up and down the watershed. And I know we've had a couple of hotspots, and I'm trying to recall if those are related to tiled fields. I think that they are. So when you talked about pre-filtering that water before hitting the slag pond or slag filter, basically you're looking at settling out the silt, right?
As much
so
as you
that,
can. Yep.
yeah, okay. Because basically, isn't it the nature of phosphorus that it would typically travel with the soil? It clings to the soil. So you got to get some of that.
Yeah, for sure. Particulate phosphorus certainly does. But the filterable or the ortho that we're talking about will stay dissolved. Okay.
Oh,
so
okay. Okay.
that's the difference.
Okay.
And so, yes, I mean, honestly, you would get with some kind of a sediment stilling basin. Maybe that's not a good term either, but nonetheless, some way to sort of pre-treat that where you can get that sediment to drop out. That will in fact take some of that particulate phosphorus along with it.
Okay. Another question has to do with, I guess, scalability. And our watershed, generally, there's a large ditching network, and you probably saw some of that because I know you did some research and found out some of the plots or reviewed some of the plots in our watershed. And I know that on average, our watershed flows about 22.5 million gallons a day. So there's a lot of water flow in general, but there's a lot of individual ditches. And so I'm wondering, from the scalability standpoint, or even a grant to experiment with this, if we were to do something similar to what they did at Elkhart Lake, where you identified, let's say, a tiling network where we know we've got a lot of phosphorus coming off it, is there grant money available to do that?
So the Sheboygan County got grant money, and I think you'll have to ask them where they got it from. I don't recall. I wasn't part of that. It wasn't a tremendous amount. I think they probably had somewhere around $10,000, I want to say, to build that system. And then when I came on board, they had about $3,000 or $4,000 left of it to do some retrofitting, and that. So, they were going to cover my fees and then the cost to build it. We were able to do that. It was probably the quickest plan turnaround I've ever done in my life. But nonetheless, it wasn't that expensive to do. So I guess, but I think the problem from my perspective with that is that they had a world-renowned expert design it. Her name is Alexandra Drizzo, and I don't think that well, at least she gave them, I don't know if she ultimately designed it, but she certainly gave them some kind of advice on it. And because they made it a flat system, they made a lot, I mean, there was some real issues on how it was designed and how ultimately has been working. And so, going into the next kind of pilot, I would hope that, we pay attention to, you know, the gradients and all the other things that have to go along with this in order to make sure that, you know, can you control the flow? Can, you know, there's lots of things I learned just from what I saw on that particular project, and then how we were trying to make it work. Okay. And a lot of that can be avoided in the next design. So I guess my point is that, yeah, going out and finding some land or some place to do this, I think it'd be great. I think, you know, talking to DNR and seeing if they would accept an NRCS tech standard as something under the TRM eligibility, see if that would be, because I think that'd be a great way to get some money. And if that doesn't work, then talking to the county agent and seeing if there's a producer. If you have a producer that's interested in doing something, then you definitely should be talking to the county agent to find out if there's USDA money under the conservation. I can't remember that. There's an acronym. I don't remember it off the top of my head. Nonetheless, there's a multi-million-dollar fund out there, and you can apply for money anytime, as long as you have it. You kind of go through the process, and the county conservation agent is the guy to help, or gal to help you do that. So that's another alternative. And how you know, and then it's all dependent upon how much money do you want to spend. I mean, you know, the site in Sheboygan is quite small. I think it's almost too small for the amount of volume of water that's going into it. Okay. It probably should be twice as big. And that becomes the question again, scalability. Well, do you keep digging holes, or do you find outlets that have already are sort of ditches or areas that are already there where it doesn't take, in some cases, you may not have to excavate at all. You may just simply be putting down a containment mat and throwing the material in and letting the grasses and weeds grow up through it. So you've got, you know, a sustainable multi-treatment train type scenario. I think that, you know, sometimes these systems get a little overthunk and you go, well, geez, we got to dig it. No, maybe you just lay the mat down on what's already there. And that's easy to replace too, because then you can technically, if the mat's a permanent type material, you could lift it out and replace it quite easily. But again, once vegetation's growing into it, it's anybody's guess. But I guess my point is that there's ways to do this that I think you could get a large bang for the buck with a relatively low expense.
I have a question. How long has this been used in either agricultural or any other applications?
It's brand new, Karen.
Okay.
I got involved with I first learned of this in 2016, and then got involved with helping achieve the permit to use it as a surface water tool from 2016 to 2017. That took us a year. And that was just because the city of Cudahy had introduced to them in 2016 and said, yeah, let's try it. So I called up the DNR and said, hey, we want to try this. And they went, not until you get a permit, you're not going to try it. So, you know, that put the brakes on that. But that was really the true story and how that all started. So now the approval's in place. We have a system in place, a couple of them, and that's it. You know, so the ag system is new. I mean, like, and I understand nobody wants to be first, right? But excuse me. But that's what it is. It's a new technology. Yeah.
And another quick question, can it be used, I don't even know if this is possible, at the beginning of a series of water bodies?
Sure.
Okay.
Yeah, absolutely. There's a project in Oshkosh. I had a friend of mine who was working as a stormwater guy there for a few years, and they were going to dredge out some of these old inner city ponds. And there was a series of sort of little cascades between the ponds. It was, you know, I'm sure it was just filthy water. You know, the geese live in it and everything else is going on. Well, we were we had discussed, it never happened, of using what's called marine mats. They're basically just really large scale permeable plastic mats. And we were going to fill them up with slag and literally lift them with cranes and drop them into the overfall, where the outfalls are. These so it water cascade down through it. We thought it would be brilliant. Again, didn't really think in terms of contact time or any of that kind of stuff. We just said, hey, anything's got to be better than nothing, right? So we didn't do it, sadly, but certainly I thought it was a great idea. But I think there's these opportunities out there. And since, like I say, since the NRCS now has that tech standard on in their field guide, that opens doors because it's not specific to how you build it. There's a handful of technical requirements. One is being a 10-year design, which I can't agree with because this is a water quality element in an agricultural application. You're really not looking to store water, you're looking to treat water. And that's the only problem I have with that issue. But they open it up to essentially however you want to design this with whatever media you can find that you think will work. So it is kind of the wild, wild west out there when it comes to this design. And I just look at practical applications. Where would it be practical to use this and not create problem for maintenance? Maintenance is a big thing. If you throw it somewhere and some guy's got to be out there mowing a damn ditch and he runs into this stuff, he's not going to be a happy camper if he doesn't know about it, right? I wouldn't be. So, I got a piece right here. If you all see this, here's, it's probably not, I'll put it by you can see it's kind of vascular. If you've ever seen lava rock, looks just like lava rock. But this is a 2-inch stone. So it's pretty big. Like I say, even if that's in a ditch, some dude on a riding lawnmower is not going to be a happy clown going over that. I guarantee it. He's going to be flying out the chute at the cars or whatever. But again, those are the things you have to think about when you do design. It's not just lay it down. You have to think of all the other little idiosyncrasies that are going to go along with it. In the case of anything that's under permeable pavement or whatever, there's no maintenance issue there at all. Okay, it's gone. It's under the pavement. If the pavement has to be taken up in 10, 15 years, maybe that's when you replace it. If it's still working, you leave it work. That's really how it goes. So.
Hey, Todd?
Yeah.
Can I ask one more question?
Sure.
Just one more. I'm sorry, Scott. I just wanted to ask, is this only for big applications or can you use it for a small application?
No, I think it has any application that you can think of, it'll work. It'll give you some phosphorus removal. So in the case of, say, using it in a rain garden for a home, I would say, why not? Sure, why not? It's going to do something. I actually, believe it or not, got so much samples, 5-gallon buckets from Phoenix Services that I actually do have an area where I get a lot of runoff off my driveway, and I'm using that as my little treatment system. Whether it's doing anything or not, I look at it going, I'm doing my job here. So.
Thank you. Scott?
I was going to ask a question for Mr. Provost, unless he wants to ask himself. Scott Provost.
Is he on?
I don't think he's with us.
Scott?
I didn't see him sign in, so I'm not sure he's with us.
Listed
No,
down.
he can't unmute.
Oh,
So, Todd, his question is, the blast furnace slag is a permanent addition? Question mark?
Is it permanent?
Yeah,
Yeah,
that's, I think the gist of his question, yes.
yeah, sure.
You can model the longevity of it, as you mentioned before, Todd, correct, by looking at the flow and concentrations.
Yeah, we can get like I say, a very conservative look at that. Like I say, because it's based, well, if we know what the concentration is, it helps a lot. A lot of times we're kind of asked, well, how long is it going to last? Well, how concentrated is the phosphorus coming in the source, right? And in the case of agricultural scenarios, your source phosphorus is going to be high in the fall, more than likely, and probably high in the spring. In the summertime, you may not have much of anything. So you have to kind of look at it from a flow weighted average perspective. But yeah, we can then at least get a sense of how long that'll last.
And then, again, I'm asking this question for Scott Provost. Will the blast furnace slag release P in anic conditions?
Anaerobic? No. No, actually what happens is the water actually causes the calcium to leach, and that bonds with the orthophosphates to create calcium phosphate. And that's essentially drops out almost like an alum. And it's now a permanent organic bond. It's no longer reactive. And no, it does not go back, does not separate and then send phosphorus back because of some kind of degradation. That doesn't happen.
Great. Thanks, Todd.
So to Scott, who can't talk, I guess, is this something that the DNR is looking into? Oh, he's asking, have you tried this in septic drain fields?
It was tried in Sheboygan by Sheboygan County in a septic system right on Elkhart Lake. They took me to it. They showed me where it was, but I don't know much more about that. I think if you had a discussion with the county about that, they could explain to you how that was set up. I think that was done in a series of tanks as opposed to using it as a field aggregate. I suspect it could be used as a field aggregate and probably do some really good things.
Hey, Todd, I have one more question for you. And again, it relates to scalability. And I'm recalling what you said about the experiment they did at Elkhart Lake. And I think you said that one of the problems they had is that the water was only staying within the confines of that, if you will, that pond or whatever for 10 minutes. And I think you said ideally it would be there for an hour to filter out the phosphorus, right?
Well, if you look at how we evaluated the phosphorus removal using 3/8 inch stone, what we were seeing is that after an hour, we were getting literally 100% orthophosphate removal under all three scenarios of phosphorus solutions, 1, 5, and 10 milligrams. So that would suggest to me that if we had, I'm not sure. Well, I know what the phosphorus concentrations are based upon the monitoring, so we're not even close to 10 milligrams per liter, but we are high enough where if we had, I think, a longer residence time for that stuff to react with the blast furnace slag, we'd actually get better results, because I think initially I thought we needed to make it go through the system quicker, but now I'm looking back and say, well, we need it to come into the system, but now we also need it to kind of sit there a little while longer. So just to give you a sense of why, residence time is so important. In the case of the urban design, I actually designed in the subsurface gallery, stone gallery, or a blast furnace slag gallery, which was 10 feet wide and roughly 4 feet deep. I designed a series of semi-permeable membranes, so the water would come into the system via the permeable pavement and then spread out across that entire 10 feet and then drip down through, creating that travel time or that contact time. And that was done not only at the top, but also midway down and then right at the bottom, so that it had to spend a lot of time touching that aggregate. And I think that's certainly one of the reasons why we've seen such positive results, because it actually is getting that contact time. So in the case of Sheboygan, we just don't, you know, to try to retrofit it, I initially said, well, at the very end, we need to put in some 3/8 inch stone, which will even slow the water down a little bit more. And I said, actually, and it'll act like a polishing type stone because of the surface area. Well, they had such bad experience with 3/8 inch stone that's now, you know, this pad of concrete that they didn't want to use 3/8 inch stone again. And I said, all right, well then we'll use this. But we should have probably used a baffle of maybe even a geotextile baffle in there to get the water to hold back before it gets to the outlet. And I think we might have, that might have been a better solution. But again, this is, as we think in terms of how these systems are going to work the best, it really is, got to make sure you get the contact time. You got to make sure that we don't pile it full of sediments, obviously. I'm talking agricultural stuff here. You got to know roughly what that, that initial phosphorus level is, so you might have to take a sample or two of some drain tile outfalls, and then you can scale it based upon that. And I think that's the important part. You can't just say, well, gee, it's going to be a 10 by 10 by 50, 4 foot deep hole, kind of stuff. You just can't do it that way. You gotta put some thought into it, sadly. And well, not sadly, for me, it's a good thing, but you really do. You can't just, there's gotta be, be able to talk in terms of true scalability and true cost. There has to be some knowns that you can apply to it to say, this will be the best way to do this.
One more
Great.
question. I just gonna ask a quick question. How much would this cost? Is this per whatever? Is it
Well, so just to try to give you a sense of cost, the material actually at Gary down in Indiana, you can get for about $10 a yard, $10 a ton, okay, or less, depending upon what I guess, how much you need and where you're going to go with it. To bring 50 tons of material up to Sheboygan, the cost was bumped up to $35 a ton. And that was simply because of the cost of trucking, okay? So, it's all a factor of how much is being needed and then, how do we get it here? If you need several hundred tons, I would say they probably put it on a rail car and take it to a distribution spot and you get it pretty cheap. That'd be my guess. But if you only need, a couple, 100 tons, they're going to ship it up in a truck or two, and that's going to run you probably $40, $50 a ton by the time it's all said and done. So as I had talked to the guys at Phoenix Services, of course, they're in the business trying to sell aggregate, and they'd love to see this windfall of everybody wanting to use slag material. I mean, right? I mean, and in the Wisconsin River watershed, which you all are part of, the TMDL is almost 100% phosphorus removal. So, I mean, there is a potential gold mine for slag applications up and down the Wisconsin River watershed. There's no question about it. It's just a question of how it's applied and who's willing to kind of start taking those steps to do it. And again, getting some, we've got acceptance from the DNR. They've seen this stuff. We've presented all the information to them. They're excited about it. They just want to see some applications. And I think that, wherever they can help, they'll help. I wish they could help us find some grant monies, quite frankly, where they could help. Honestly, that's my pitch there. But because I've talked to them a bit about the TRM application and how the USDA code is out there, and if that would apply, I still haven't got a good answer from them yet, but I haven't got a no, so I can keep asking. But I think there's obviously some. To me, from a state perspective, that's one place you got to look. The USDA stuff is a little bit more complicated, but I can't believe it's that difficult to get either. It's just having the willing people to do it.
Okay, Todd, one last question. Is it all right if I share all these slides with the people on the call?
Absolutely.
Okay, how about your contact information? Do you mind?
Yep.
Okay. All right, sounds good. Well,
Any
thanks.
questions you guys have or anything else, don't be afraid to give me a call, drop me an email. I'm here to help. I like to see something happen more than what's out there. And you know, this is something, I'm not far from retirement, so eventually I got to walk away from this. So I'd actually like to see some of this stuff happen before I pull the plug. About a year away, so.
All right. Well, Todd, thanks a bunch. This was really, really interesting, and I
Good.
appreciate your taking the time to share all this with us.
You bet.
Thank you.
You betcha. Thank
All right.
you.
Have a good day, sir.
You too.
Thanks, Todd.
Bye.
Okay, so y'all can hear me, right?
Yes.
Okay.
Yeah.
So the next item on the agenda is 9 key element status. I didn't hear anything from Kason, but I noticed that Anna is on the call, and I was wondering if you had anything to share with us that Kason may have imparted with you.
I don't have anything to share about the 9 key element plan specifically. Kason hasn't given me any updates on his end. So,
Okay.
but hopefully we'll be hearing something soon.
Okay, yeah, I'll give him a shout after the meeting. Thank you. So the same with the video, I have not heard yet. And regarding the flyer and mailer, my name is on there along with Karen, and I've done nothing. Karen, I think we're on a holding pattern with that. Is that right?
Well, until we get together with Kason, isn't that what we're?
Yeah.
Yeah.
Okay. Next item is creating the YouTube channel. Anything new on that, Karen?
I've been working on it, but I don't have a lot of videos for it.
Oh, okay.
So I have to figure out if I can just use any, thing off the internet, because I don't think I can. I think you have to have the MP, whatever, the MP4. I think Phil probably knows more about this than I do. A certain format, according to what I saw, to put it into the YouTube. So that's going to be a problem. And then we've got the 2 videos, but we need the 3rd, but we're waiting on that.
Yeah.
So I really
Okay.
can't do a lot until we have content.
Gotcha. Okay, thanks, Karen. So the next item is some of us had, if you remember, Rachel Whitehair had put on a Central Wisconsin Farm Profitability Expo, and I watched it. I thought I saw Scott Bordeaux and John Andresi on it as well. So I threw it out here on the agenda to see if there was anything that either of you guys had to share about it. Scott, anything?
Well, I listened to a couple of them. Are you talking about the Rick Clark presentation? Or are you talking about the grazing?
Yeah, I think it was a Rick Clark presentation.
Okay. Yeah, I'm extremely interested in and really enjoyed Rick Clark's presentation, and I'm wondering how we can figure out how to get people to farm for carbon up here, and how we can get either the county or the DNR, to help support carbon farming, which is basically, going back to the healthy soils, cover crops, no-till. Real interesting about how when you have vegetation on the fields, it's grabbing, your carbon dioxide out of the air. So I've been thinking about that. I haven't come up with a solution, but boy, if we could get some funding somehow to help support that, it's doing a bunch of good things, I think. So Rick Clark, a very dynamic speaker, great presenter. It was a quick 4 hours when I listened to it. But yeah, he's doing some great things.
Thanks, Scott. John, anything to add?
No, I don't. I'm drawing a blank on this one, Don. I don't remember seeing it.
Oh, okay. Yeah, I know we watched a couple, and between Heidi's advertising the expos they put on and the one that Rachel did, I probably have them mixed in my own head. So let's move on. So the next item on the agenda is the future videos, Zoom sessions. And that's the discussion that we had with Rachel. And of course, she's not here to share in that discussion, but it was based upon our showing of the movie and Kiss the Ground. And because a number of us felt really good about that, we had talked about identifying some additional videos that we would co-promote with Rachel. So again, Rachel's not here to talk about it. Does anybody else have anything to add?
Well, I had sent her a few videos, but I think she's not going to use them. So I don't know, you know, documentary things, but.
Okay. And I mean, I appreciate working with Rachel, but we could do that on our own, just as a 14-mile committee. If you think it's worthy, Karen, you know, put it out there on a future agenda and we'll take a look and we could sponsor it.
Sounds good.
All right, thank you. So then quickly, the status of grants. And Dave, my understanding is, I think the date for awarding the grant is February 15th. Is that right?
That's right. So we're in a holding pattern for about another 5 weeks.
Yeah, okay. So we won't know anything till then. I'll leave it on the agenda because a month from now we'll be meeting again. Taylor, anything new about the wetlands?
I really don't have anything new to report since last month. We're still working on securing permits and writing a project to install monitoring wells out there, but that's really about it right now.
Okay. Are we still looking at this coming year to execute this?
Yes. Yep.
Very good. Thank you. Okay. This next item I've titled Committee Direction. And we've had a lot of, I guess, a lot of recommendations made and about where this committee goes. And it was discussed at various meetings, some of the Tri-Lakes meetings, some of our own meetings, where we've talked about what we can do as a committee to sustain this committee for the 10 years or for the life of the 9 key element plan. And so it's been discussed that we really need a committee structure that lives at least through that 10-year period. And actually, in the 9 key element plan, it refers to the 20-year life of the TMDL. And from Kaysen's perspective, he says, you guys need to be thinking beyond that. Well, I'm not going to tell you how old I am, but I'll be pretty old in 20 years, and I don't think I'll be involved in the committee. But anyhow, the point is that we need to be thinking about that for the long-term viability of the committee. Also, a number of our advisors and some of the organizations that we've reached out to are telling us that we really need to open up this committee so that we can bring in all stakeholders in the watershed. And some people have the perspective that we're really about the lakes and Rome, and really that's how we all started out. And so the recommendation is that we need to open up so that all of our upstream neighbors would feel comfortable being a part of this organization. And that gives us a greater watershed buy-in and less us and them kind of mentality. So I agree with that. And then one important part, our experience with grants to date shows that typically they require 25% match. And give you an example of the 2 major grants that we were involved in this year. In both cases, we had to secure a promise from Tri-Lakes, and they were very willing to do this, that they would cover 25% of the cost in the seasoned employee that Kaysen would hire as an example. And so recognizing that if this is a 10-year, $8 million plan, then potentially there's about a $2 million co-funding number that we need to be aware of. And so we need to think in terms of where does that money come from? I mean, certainly we can't go to Tri-Lakes and the town of Rome and expect that they're going to cover this over that 10-year period of time. And so one of the key questions is, how do we access under other funding sources? And so we've assembled an informal work group to look at this. And one of the things we did is we rewrote the mission statement and goals, because a number of people have pointed out to us that the mission statement and goals were written in 2016 when this group first started. And so the group itself and really our direction has grown quite a bit. Back when we wrote that mission statement and goals, we had no idea what a 9 key element plan was. And so certainly the 9 key element plan is the driver now, based upon resolutions written by the town and by Tri-Lakes. And so we need to be cognizant of what that means, especially where the milestones are occurred. So anyhow, we put this informal work group together, and our objective was to identify additional funding sources, make the committee more inclusive to all stakeholders within the watershed, while maintaining the original link with our community, with Tri-Lakes and with the town of Rome, and then to provide focus to the implementation of the 9 key element plan and establish that long-term viability of the committee. So as I mentioned, we rewrote the mission statement and goals. The next step is really look at the long-term viability and the funding aspects of it. And the conclusion we arrived at is that we need to organize our committee as a nonprofit group, like a 501c3, in order to give us access to other areas of expertise, but also to funding, which is one of the key areas. One of the citizen groups in Wisconsin, or many of the citizen groups in Wisconsin, are 501c3. And that enables them to take donations and also access grants from private funds and individuals. And that would be money not typically available to a municipality or to an organization like Tri-Lakes. Also, I shared a couple of web searches that I did of watershed organizations. There was one in, I believe it was New Jersey, and another one in New Mexico. And as an organization, they had identified different grant sources. And the thing that amazed me, and I think it was about probably the New Jersey website, there were 150 different private firms, family groups, other entities that offered grant money for conservation-related projects. And I think that's interesting. And if you look at, like our friends at Wisconsin Wetlands, they're a nonprofit group. If you look at the group of their donors, I think there's about 100 private donors out there. So I think there's something to be learned. So if you think about our own environment here, if we have a well-structured community, we really have access to a 4-county pool of potential donors, thousands of lake dwellers, and a number of industry groups upstream. Got the cranberry growers, got some potato vegetable growers. So anyhow, that's the approach that we've taken, is we should look at that seriously. And I've talked about it with Carl. I called Carl Hasdall the other day just so that we can all be transparent about what we're thinking of and to share with him. And his suggestion was we should really think about, if we create a board of directors, we should think about including the other 3 counties to make sure we've got their buy-in, but also because they're recipients or involvees in the watershed, that they also help fund any of the work that gets done. So in initial discussions we've had, we're talking about putting together a group that would have a first-year group of officers, a traditional group that typically would be like a president, vice president, treasurer, and secretary. And then through a lot of discussion, it's been recommended that we should have a 7 to 9 member board. And I think we're leaning towards 9 member. And in that board, we would have Tri-Lakes as one of the board members. We would have the town of Rome as one of the board members. And then we would have representatives from the ag community, potentially from the row crop community, as well as the group from the cranberry community, and potentially people from the other counties. And that all has to be worked out. So the other thing I think that's really important is because in a 501c3, you have you have a certain obligation to find funding. I mean, that's one of the primary reasons why we would do this. We need to have a really well-organized structure. I mean, just to throw out a few names there, Dave, as an example, has done a great job with grants, and in a way, finding money on the outside through private entities is a lot like requesting grants. So we have some experience and expertise, and Karen, certainly in some of the work that she's done, there's another person. And as we expand our committee, or our, if you will, our approach or our exposure, I think we draw in more people. And so I think that's a key part of it. So our next steps, I want to talk at Wednesday's Tri-Lakes meeting. As I mentioned, Carl and I have talked about this. I want to talk more with the Tri-Lakes board during the meeting when I give the 14 Mile update. And I know that Thursday night is a Rome Town board meeting. So I think we're on the agenda anyhow for a 14 Mile update, and I would like to talk more with that. About that. And then tentatively, we have a meeting with Nick Flanagan, the town attorney, to talk about this on Friday, a Zoom call with him, just to see what direction we take with this. So anyway, I wanted to bring you all up to date on that in terms of the direction of our committee. So any questions about that or comments? Okay, hearing none. Next item on the agenda is upstream water testing. John, is there anything new to report?
Excuse me. I have completed 37 months of testing as of the first of the year. All 37 of those months, the tests, chemical tests, were handled by the Water and Environmental Analysis Lab at the University of Wisconsin-Stevens Point. I've developed a very strong relationship with the people that the lab there, and within the water community at the university. People like Bill DeVita, George Kraft, Dr. McGinley, and in particular, Jess Hockey. Due to the situation that has arisen regarding our change, going to a nonprofit and other aspects, well, now we've gone for this grant that will hopefully be approved in February, and the monies from that are going to help to support us to be independent. And having said that, the move is anticipated to be made to the State Laboratory of Health at Madison. Just to say that I'm very happy to have been involved with people at the university, and suffice it to say that's not going to end by any stretch of that imagination. So that's a big thing that's gone on for me and us. Other than that, I think I may have mentioned last month, and if not, I've established a new testing location. It's in place of an old location on the Leola ditch, the last point that I was testing on the Leola ditch. It's been pretty much inundated by silt, and it's become extremely dangerous to test at that location. So I've moved the spot up to the 6th Avenue crossing. Basically, that's what I have for a report right now. Thank you.
Okay. Hey, John, a question, and thanks for bringing up the change in where we do the testing. Where are we prepared to do that with this month's testing? Then we'll send the samples down to the lab in Madison. Are we all set with that?
No, Taylor's. I'm sorry, Don. I didn't mean to interrupt you. Taylor, Scott, and I are going to have to sit down together to get everything set up and whatnot. I'm going to be needing containers and a supply of chemical reagents and things of that nature. Rest assured that it'll be taken care of. My test for this month is scheduled for the 26th. So we have a couple of weeks to get this in. I will be making an appointment with those two after the meeting.
Okay, okay, good. So it sounds like we're all set then for this month, for January.
Yes.
Okay, good. Yeah, because I had shared that with Carl and indicated to them that the DNR would be picking up our test costs effective this month. So sounds like we're all set. Thank you, John, for taking care of all of that. Appreciate
You
it.
bet. Thank
For
you, Don.
Taylor and Scott as well. Phil, I know we're done testing in lakes. Anything new to report at all?
Yeah, just real briefly. Last fall, I worked with Anna James of the Adams County LWCD to put together a list of our needs in terms of equipment and supplies for our testing this summer. I did talk to Anna this morning, and our request has been approved. And we expect to get delivery on all the necessary equipment and supplies in the spring in time for our summer testing. So I see Anna's on the call. Thank you, Anna, for your help with that. The other thing is we're going to get some additional equipment that will be able to set up a fourth test team to cover Camelot South. And split the Camelot testing into the two pieces, which I think will simplify things quite a bit. And beyond that, we're just waiting to see whether and when we can start our testing this spring. As you know, last year we had a late start because of COVID concerns, and I guess we'll wait for the DNR to decide exactly when we can start this spring. I hope we can begin in May, as we've traditionally done. That's about all I have.
Okay, thanks. Thanks, Phil, and thank you, Anna, as well. So Dave, anything new to report on Healthy Lakes?
Well, as I mentioned earlier, the 2021 grant, we're about 5 weeks away from hearing. With a little bit of luck, maybe we'll even hear something before our next regularly scheduled February meeting. Other than that, I do have the Healthy Lakes fish sticks project that's funded for Lake Sherwood. If we get a little bit of sub-zero, I'm hoping we get a foot of ice or more near the islands. If that's the day that we get that, will be the day I'll start making calls and pulling in favors, getting folks to help get some trees cut, transported on the ice. I have already given my contractor a heads up that transports trees for me every year. So like I say, if we get enough sub-zero that we get about a foot of ice, we're going to go like gangbusters. I'd like to get a minimum of maybe a group of 24 trees out on the ice. That would be 6 bundles. I've got trees lined up that I could put out as many as 80 trees if we get a good 3 weeks of sub-zero in February that gets really good ice. So it's all weather dependent right now, but I'll be contacting folks for some help. Not only our Lake Sherwood residents, but other folks in this group and beyond that might be interested in helping with that.
Excellent.
Okay, that's all I have. Thank you.
That is really good. So I'm sure I brought this up last time we met, but I think we're over 50 projects now, aren't we? From the time this committee started, and I mean, I don't want to take credit for it because it's largely you, but I think over 50 Healthy Lakes oriented projects since the start of this.
Yes, we started in 2017. Barb actually gave me a call from Tri-Lakes and said, hey, there's a new program we're learning about. Do you have any projects on Lake Sherwood? I said, I'll find something. I'll get back to you. So we've been going, started with about 3 or 4 projects in 2017. So now we're up to, like I said, 25 projects applied for 2021. So making some big strides, and hopefully it'll expand. And if that's the case, I'll expand our Healthy Lakes Committee subcommittee.
Great. Yeah, really great work, Dave. Thank you. So outreach, let's see. I sent around a document this morning and about one of the programs, Wisconsin Wetlands, and it was their newsletter. And it was really pretty interesting because it didn't refer to us, but the kind of work that they do is exactly what went on this fall when we were up in the DNR land, looking at the wetlands and what we can do with potential denitrification. The second document I'll send out this afternoon, and it's interesting because Heidi Keeler, who spoke with us, I think the month before last, she sent me something. She said, Don, this might be interesting to you guys. And it was from the state of Michigan, and they have a program that is somewhat like Healthy Lakes. And I was just so impressed by the newsletter itself and just the professional look out at it. And they had featured a number of families who on their shoreland had done improvements for various problems, like some had really damp, swampy soil, and others had runoff problems and that kind of thing. And it reminded me so much of what we did last year in our recognition program for our clean water cooperators. And it really, I'm excited to start that program again next year, but I want to send that thing along and y'all have a look at that, and maybe you'll get excited about doing it too. So next category is lake reports. Anybody have anything to report? Start with Petenwell. Anything, Scott?
Yep. I guess the one thing I just wanted to bring up was the Clean Water Now campaign that River Alliance is trying to get going, and heard that the Wood County Board has passed that resolution, and that will be on the referendum in April. So we had Bill Clandemi that comes to our Packers meeting, and I, appreciate his efforts on getting that. I know they're talking about it, and I don't know, Paul would know more if where they are with Adams County. Nothing else directly with Petenwell, although I guess at this point I would like to say that if anything further goes on with Todd Weik, put me first on the list as a volunteer.
Okay. Yeah, thanks. So just one question. I think I'm familiar with that Clean Water Now, and that's a legislative approach, right? Scott?
Yes, sir.
Yeah, okay.
Could you give us a brief background or encapsulation of the wordage for that, Scott?
I don't have that.
Okay.
What the resolution would be, I don't have the verbiage on that. I just saw a blurb from River Alliance that it has passed the county board in Wood.
Do you have an idea of what it generally is about?
It's a non-binding referendum to show unity, throughout the state. I guess they're coming from it from the standpoint of, the political environment. Doesn't matter who's in charge or what's going on. You can't seem to get anything done. So they'll bring it down to a county level that, we're interested in clean water, surface and groundwater. And so the River Alliance is kind of running this, helping the counties get going and get this, passed as a resolution on a referendum.
Is it for the county or is it for, what is it for, the county?
That's correct.
Okay, so Adams County, what county is this?
Well, this one, they're working on a couple, three, and again, Paul Piccolini is more involved with Adams, but Wood has already passed it, is my understanding.
Okay.
So it will be on the April ballot.
Wonderful.
Okay. Hey, Barb, would you put a to-do out there for me? I've got the document from Allison, and I'll send it around to all of you.
Thank you.
Okay, and then I just got a question from Anna, the ice report. I don't know if it's official, but my dog Harry and I walked out and drilled a hole, and it was somewhere about 6 to 8 inches.
All right.
That's the ice report for Pete. Well,
Thank you, sir. Any report for Arrowhead? Nothing? Okay. How about Sherwood? We're making our
Yes,
way east.
I'd like to bring up that Sherwood property owners, my conservation committee is having our fishery this weekend. Also, we're seeing 6 to 8 inch ice depth. So I expect to see foot traffic. I expect to see snowmobiles and ATVs. I don't expect to see any vehicles larger than that, but there's no accounting for stupidity. We had a couple last year on the ice that fortunately did not go through with it, but I never would have been out there with the truck last year when we had about 9 inches of ice. Anyway, so I'd like to invite people to participate in that. And even if you're not an ice fisherman, stop by and visit with us at our booth out on the ice in front of the lodge and buy raffle tickets for some nice prizes. That's really where our profit is made, is solely dependent on the number of raffle tickets that we sell. So hope you can help promote that, and folks on our call here today can come by and see us on Saturday. We'll be there from 8 to 4, and Karen, I'll probably call you just right after this call.
Good. Let me ask you this. Did you find anybody who has a snowmobile or ATV?
I've got 2 or 3 people now after our board meeting last Saturday. So we're not quite what I'd like to have, but we're in much better shape than last year. So I think we're in pretty good shape as far as getting our raffle sales out on the ice. If we can visit every fisherman at every fishing hole, that's when we get our best raffle sales. So that's what we try to do.
Sounds good.
Thanks, Dave. How about Camelot? Any updates? I thought I saw Carson on the call.
Here. Can you hear me?
Yeah. Hi, Carson.
A lot of ice fishermen now. I don't know if they're catching anything. So I would have at the same ice depth as there. But there's been probably more activity as far as ice fishermen than I've seen in the past. So that's a good sign. Seems like people are coming up and down on the channel with ATVs and snowmobiles. So the ice must be, relatively thick. I walked out there about a couple weeks back and just looked down one of the holes. It looked like about 6 to 8 inches, I would say. Can I make another comment? And I would just go back to the idea of the subcommittee for our review of our mission. And I agree fully with you that needs to be looked at. And I think it's a good idea to have a subgroup to look at that, because it really changed just in this matter of a couple of years. So I applaud you for that. And I think our mission has changed a lot, especially with the 9 key element plan being accepted finally, because we put so much effort into that. I think we really need to know where we're going from here. And I think, again, there's been a lot of changes, and I think our committee needs to look at what our mission is going forward. So that's my speech.
Thank you, sir. All right, good. Thanks for the lake updates. Any town report?
Yeah, we haven't got a lot going on other than we're going to be approving some more rezoning where we've got another 140 some acres coming out of forestry going into residential subdivision. That's got to be a monthly thing. So we're rapidly losing our forestry, which is a serious problem. And unfortunately, our county land and water is responsible to try to get more land into our county forest, but Cason's been very busy on other things, I guess. But it's a concern. But other than that, other business.
Thanks, Sherry. How about county?
I have no report on that.
Okay, thanks.
Don?
Yeah.
Is Kason invited to, he's sent out on the email, right?
Yeah.
Okay, but he's not here right now?
Right.
Okay.
Don, Kaysen will be out all week. So if you try to get a hold of him, just
Oh,
to
okay.
let you know that.
Okay, yeah. Yeah, I'll just tag him and ask him to call me when he gets back in. So. Okay, any Tri-Lakes updates? I didn't see Bob on the call, so presume we don't have an update. All right, so next agenda. February 8th, work okay with everybody? It's the second Monday.
Yes.
Okay, hearing none, that's okay. Any topics you would like added? Okay, if you come up with something or if something comes up that you want added to the agenda, just let me know by about 2 weeks or so from now. I typically do the agenda about 2 weeks before the meeting. All right. With that, I'll take a motion for adjournment.
So moved.
Second.
All right. Thank you all very much for your time. Appreciate taking this time with you.
Thank you.
Thank you.
Thank you. Bye.
Bye now.
Thank you all.
Don? Don?